All right. Now, we're going to learn about something interesting. Develop our modular arithmetic system even further. First, let's develop some intuition. In math, intuition means the feeling that's going to lead to discovery. And that feeling being determined by patterns we see in using regular numbers. So let's see. Notice that 1 is congruent to 9, is congruent to 17, is congruent to 25 under mod 8. This is what we have going on in our column over here. However, if we count up from 1 from each of those integers, their results are also congruent to each other. So 1 plus 1 being 2 is congruent to 9 plus 1 is 10, which is congruent to 17 plus 1 is 18, which is also congruent to 25 plus 1, which is 26, under the modulus 8 system. So, going up 1 in each value, we get another residue class where they're all congruent. That's interesting. We added 1, and we find that the results are still all equal, just like in regular arithmetic, where if I had 1 plus 1, I don't know what the equivalent in regular arithmetic would be, since you don't have, like, whatever. Alright. So, we're basically going to develop an addition system under modular arithmetic. Using this intuition that plus 1, if you add plus 1 to things that are equal the whole time, then it maintains the equality. So, we want to show that A1 plus 1 is congruent to A2 plus 1 mod 8 for the first part. We can assume that this is true. We can assume that that's true. And by assuming that that is true, we get the following. I mean, this is something I've done plenty of already. A1 and A2, if they are congruent under mod 8, then that must also imply that A1 minus A2 over 8 equals K, and I'm just going to state up here, K is an integer. We have used this property extensively already, so I'm not going to dwell upon it for too long. We know that that's true. So, part A. We want to show that if we add 1, the equivalence will be the same. So, well, what we can do is say, let's say I have the following written out. A1 plus 1 minus A2 plus 1 over 8. This is, notice it's the same setup we have here, right? A1 minus A2. But now I have A1 plus 1 and A2 plus 1. And I want to find a difference between them, because if I show that that difference is equal to an integer, then that proves that they are congruent under modulo 8. So let's simplify. We have A1 1 plus 1. Then we distribute the negative. So minus a2, and then minus 1 divided by 8. Simplifying further, we have positive 1 and negative 1. They're going to cancel out, and we have a1 minus a2 over 8. But we have already established that that is the same as k. Interesting. Oh, why did I highlight the wrong one? I'm doing plus 1, plus 1. Alright. This has established for us something very nice, which is the fact that what we began with, our a1 plus 1 minus a2 plus 1 over 8 is the same as k. We have established that equivalence, and we know k is an integer. So, because we have these two terms here, and the difference of them divided by 8 is an integer, that establishes the fact that a1 plus 1 is congruent to a2 plus 1 under mod 8. And like everything in math, it starts from these simple definitions we worked with. The fact that if the difference is equal to, or I should say the difference divided by mod m is equal to an integer k, then it establishes the congruence relation. These two things prove each other. And that's exactly what I've just done. I've proven that the difference divided by 8 is an integer. Therefore, I have established the congruence relation. So, that is part A. Now, part B wants us to do it for subtraction. A minus 1. Is that congruent to a2 minus 1? Let's see. I'm going to use the same technique I used before. So, we have a1 minus 1 minus a2 minus 1 all over 8. And let's simplify. Keep the first part the same. a1 minus 1. Distribute the negative, so we have minus a2. And minus negative 1, that becomes positive 1 over 8. Well, we have negative 1 and positive 1. They're going to cancel out. And we have a1 minus a2 over 8 again. And we know that's equal to k. So, because we have established the fact that a1 minus 1 minus a2 minus 1 over 8 is equal to an integer k, that shows us that these two terms must be congruent mod 8. So a1 minus 1 is congruent to a2 minus 1 mod 8. And then finally, for part C, and I imagine you can guess where we're going to go with this. So part C. We have that we want to show that a1 plus b. Now a1 plus any number is congruent to a2 plus b mod 8 for any integer, positive or negative. Doesn't matter what b is, for any value at all. So, let's set it up same exact way as before. A1 plus B minus A2 plus B over 8. That is the same as A1 plus B minus A2 minus B over 8. Positive B and negative B cancel out, and we're left with, again, just A1 minus A2 over 8, which is equal to K. So, again, we have established that A1 plus B minus A2 plus B over 8 is equal to an integer K, which proves that these two terms are congruent under mod 8. So A1 plus B is congruent to A2 plus B under mod 8. So, at least for mod 8, we have established the fact that if we can add any integer to any value for A1 and A2, as long as they're the same, if we add any number B to both of them, it establishes the same congruence. Not the same congruence, it establishes that their addition will be congruent as well.